Hello everyone, welcome to Shiv's classes. In today's lecture, we are going to discuss problem number 7 and 8 from the Miscellaneous Exercise of Chapter 3. So this chapter is part of Trigonometric Functions series, and we have already discussed quite a few problems of this chapter. In today's lecture, we are going to discuss only two problems, 7 and 8, because problem number 8 would be a little longer. So I don't want this video to become very long. So without any delay, let's start this lecture. So you can see I've already noted down some of the formulae on the right hand side, because these formulae we might be using, some of this we might be using, some of this we may not be using, but these are some of the important formulae which we should be looking at, because when I looked at the problem, I could see there is something in sine theta plus sine theta's term, and I could see that maybe I may have to make use of this formula. Then I looked at there is something like sine theta and then another with another sine angle and with a negative sign. So I thought maybe we may have to use sine c minus sine d's formula, and then something like sine 2 theta as well I am seeing. So I may have to make use of 2 sine theta into cos theta, and then sine 3 theta is also there. So yeah, that formula also we might be using. So yeah, this problem is looking straightforward, and then looking like that we have to make use of some of the formulae. So let's start this problem. Alright. So LHS we have taken, we have got sine 3x plus sine 2x minus sine x. In such problems, what I do whenever I see a bigger angle and a smaller angle, I generally try to club them together and then leave the middle part as is, and many a times the problems generally become simpler. So let's do that this approach only. So sine 3x minus sine x I have taken together, and I am putting sine 2x separately. Now this is nothing but sine c minus sine d, and I can write it as 2 of cos of 3x plus x by 2, which is cos of c plus d by 2 into sine of c minus d by 2, so 3x minus x by 2, and then I have sine 2x, so I'll write this sine 2x over here. Now 2 of cos of 3x plus x will become 4x, 4x by 2 will become 2x. Similarly, 3x minus x will become 2x, 2x by 2 will become sine x. I got sine x, and sine 2x, can I write it as 2 of sine of x into cos of x. So you see that on the right hand side we had to have something in sine x, and something like sine x is appearing twice over here. So we'll just take 2 of sine of x common. So we will be left with cos of 2 of x plus cos of x. Alright. Now looks like we need to know another formula, which is cos c plus cos d. And I hope you remember this formula. If you don't, then I'll just write it down for you. Just do remember such formula, because it will become easier for you to solve such problem. So 2 of cos of c plus d by 2 into cos of c minus d by 2. Alright. Now write this as 2 of sine of x into 2 of cos of 2x plus x by 2 into cos of 2x minus x by 2. Right. Now this 2 and 2 will become 4, 4 of sine of x, and then this is cos of 3x by 2, and this last one is 2x minus x by 2, this will become x, and this will be cos x by 2, alright. And probably this is what we had to prove on the right hand side. If you look at the expression, we just have to rearrange it. We have to rearrange it like 4 of sine of x into cos of x by 2 into cos of 3x by 2 is what we had to prove on the right hand side, and this is right hand side is proved. Alright. So yeah, this example was based on some of the formulae which we have learned earlier in this chapter. We just have to make use of such formula. You could have started with 3x plus sine 2x as well, and it wouldn't have made much of a difference. Just that I tend to club the bigger one and the smaller one together, and generally it gives a better result, right? Now going to the next problem. In the next problem, I have been asked to find the value of sin x by 2, cos x by 2 and tan x by 2, wherein tan x equals to minus 4 by 3 is given, and it is in second quadrant. So what it is saying over here is that this is your coordinate system, and you are going to be in second quadrant, and the tan theta tan x value, this is going to be x, the value of tan x is going to be minus 4 by 3. Alright, so minus 4 by 3 is the value of it. So you know that you can just have it like minus 4k and 3k, and rather plus 4k and minus 3k, because x would be negative here and y would be positive over here. So using this, you should try to calculate the value of sin x and cos x as well. Alright. And why do you do that? You should calculate value of sin x and cos x, wherein you were asked to find value of x by 2 and sin x by 2, right? Because once you get the value of these, then the other values will be easier to find. So what are we going to do? Why we are trying to find such things is because we know some of the formulas here. So let me write some of the formulas which we know. So we know that tan of 2x is nothing but 2 of tan of x divided by 1 minus tan square x. We also know that cos of 2x is going to be 2 cos square x minus 1 is 1, or 1 minus 2 sin square x, right, is another thing, right? And we also know if we have sin 2x, I can just write 2 of sin of x into cos of x. In all these cases, if say instead of 2x we put x, then all the formula will change accordingly, right? So I'll just write one of those things wherein I am assume 2x equals 2x is what I am assuming. So my tan 2x will become tan x, and this part will become 2 of tan of x by 2 divided by 1 minus tan square x by 2, right? And similarly cos of x will become 2 of cos square x by 2 minus 1, or 1 minus 2 of sin square x by 2, and stuff like that, right? So this is what we are going to use. And as you can see, if I have the value of tan x, so I can get the value of tan x by 2. Somehow this will become a quadratic and I'll be able to get the value. Similarly cos 2x, if I know the value of cos x, I can just put the value of cos x over here and then get the value of 2 cos square x by 2. So this is what I am going to do. Alright. Here I am just trying to get the value of tan x. Out of that, I'll just try to get the value of sin x and cos x. So this is one of the ways of doing it. Alright. So if we know the value of tan x, what we used to do earlier, if you remember, what we used to do earlier was we used to have sec square x minus tan square x equals to 1, right? And what we used to do, we used to do sec square x equals to 1 plus tan square x, and we used to have 1 plus minus 4 by 3 whole square, and that would be 1 plus 16 by 9, and that will be actually 25 by 9. If you sum it up, 9 will go here plus 16, and 16 plus 9 would be 25 by 9. So I will write sec of x equals to what? Square root of 25 by 9, right? And this will be nothing but sec of x would be plus and minus of 5 by 3. But it is in the second quadrant, so we know that what would be my sec theta? My sec theta is also going to be negative, so I'll use minus 5 by 3. Once I've got sec theta, can I get cos theta? Yes, I can get cos theta. So my cos theta will be nothing but minus 3 by 5. It will be reciprocal of that. Once I've got cos x, can I get sin x? Because I know that sin square x plus cos square x is nothing but 1. This means that sin square x is going to be 1 minus cos square x. Alright. And I am going to put this value. So I'll get sin x equals to square root of 1 minus 3 by 5 whole square, and that will become what? It will become 1 minus plus, this will be 9 by 25, and this will become, if I do this, it will become 25 minus 9 by 25, and which will be nothing but 16 by 25, right? So sin x will become what? Sin x will become plus and minus 4 by 5. But we know since it is in the second quadrant, sin x equals to plus 4 by 5. Alright. So we were supposed to get the values of sin x by 2, cos x by 2, tan x by 2. Instead what we have got is rather sin x and cos x, and you would see that why we did that is because this is what we are going to make use of to get the values of sin x by 2, cos x by 2 and tan x by 2. So once we are done with this part, let's move on to the next part. So I'll just go to the next page. My tan x is going to be minus 4 by 3. Now, as I said earlier, I can write it as 2 tan of x by 2 divided by 1 minus tan square x by 2, and this will be equal to minus 4 by 3. And from here on, what I will do is I will just assume tan x by 2 is nothing but y. Why did I do that? Because I need to calculate the value of tan x, and looking like it is going to become a quadratic. So I am going to write 2y divided by 1 minus y square equals to minus 4 by 3, and then I am doing a cross multiplication, so I will get 6y, this will go this side, equals to minus 4 and then plus of 4y square. I will just take the 2 out from here, just remove 2, so then I will get 3y equals to minus 2 plus 2y square, because I have just taken 2 out, 2 I have just removed from everywhere, and in 2y square minus 3y minus 2 equals to 0. Alright. So I can also factorize it. So I can write 2y square minus 4y plus y minus 2 equals to 0. And I can write, taking 2y common, it will be y minus 2. I have 1 common over here, y minus 2 equals to 0. So this will give me what? This will give me 2y plus 1 into y minus 2 equals to 0. So this will give me either 2y plus 1 is 0 or y minus 2 equals to 0, right? This will give me y equals to minus 1 by 2 or y equals to 2. Alright. Now look at this. I have got two values, one in negative, one in positive. Which value I should be taking, right? Now just look back at the values which you have been given. Since you've been given that your x, basically this x is here, basically minus 4 by 3, it means that your x will lie between what? Your x will lie between either pi by 2 to pi, right? It will lie between, it will be greater than equal to pi by 2 and it will less than equal to pi. So this implies that pi by 4 less than equal to x by 2 less than equal to pi by 2. Basically I am trying to get dividing it by half. So it is giving me that x by 2 is going to be between pi by 4 to pi by 2. It means that this is going to be in first quadrant. This means that x by 2 is going to be positive. So I am going to take y equals to 2, right? I am not going to take y equals to minus 1 by 2 because my tan x by 2 should be positive. That is why I will take tan x by 2 is equals to 2. So this is the first one we have got. Now we have to get what? We have to get sin x by 2 and cos x by 2. So we had also calculated cos x minus 3 by 5. I could have even made use of tan x by 2 as well over here, but I'm just doing it this way. I'll do it in another way as well. Now cos x is equals to this. So can I write cos x as 2 cos square x by 2 minus 1, right? Because this is the formula directly. And can I write 2 cos square x by 2 is equals to 1 will go this side, 1 minus 3 by 5. So this will become 5 minus 3 by 2, so it will become 2 by 5, right? So cos square x by 2 will become 2 will cancel out, so it will become 1 by 5. So cos x by 2 will become plus and minus 1 by square root of 5. I have just taken the square root. Again, since x by 2 is going to be in the first quadrant, so cos x by 2 is going to be positive. So I am going to take cos x by 2 as 1 upon root 5 as positive. I will ignore the negative value. This is the second one which you have got, right? Now the third one, right? We have to get sin x by 2. Same way, since we know cos x is equals to 1 minus 2 sin square x by 2 also. So we will make use of this formula itself. So cos x is going to be what? Minus 3 by 5, right? So now bring this over here. So 1 plus 3 by 5 will become 2 of sin square x by 2, isn't it? Once this becomes 5 plus 3, 8 by 5, I am just summing it up, equals to 2 of sin square x by 2, then 2 4s are 8, and sin x by 2 is going to be what? It's going to be plus and minus a square root of 4 by 5, which is nothing but plus and minus of 2 upon root 5. Again, this is going to be positive, so I am going to take sin x by 2 equals to only 2 upon square root of 5, ignoring the negative value. So you've got sin x by 2 as 2 of square root of 5 as well. Alright. And as I mentioned, I could have done it in other way also. So what is the other way around is? Quickly I am going to do it. So cos x is going to be, I can write 1 minus tan square x by 2 divided by 1 plus tan square x by 2. There is another formula of it. So basically, if we had to calculate cos x value, I could have just used 1 minus 2 square divided by 1 plus 2 square. So this would have become minus 3, this would have become 5, and so we would have got cos x value also from here, which we had calculated in the beginning itself. Once we have got the value of cos x, then again you could have made use of 2 cos square x by 2 minus 1 equals to minus 3 by 5, and similarly 1 minus 2 sin square x by 2 is equals to minus 3 by 5, and you could have gotten the values. Alright, so there are multiple ways of doing it. It depends on you which one you prefer. I prefer generally to calculate everything upfront, knowing that these are the things I am going to make use of. So I will calculate values of sin x, cos x. It might become little longer to do this way, but yeah, I mean it is up to you to choose. Alright, so yeah, with this we are done with this lecture. I have just finished problem number 7 and 8. In the next lecture we will try to finish problem number 9 and 10, and with that we will conclude the miscellaneous exercise of chapter 3. Alright, thank you for watching this video. If you have any question, please do ask me in the comment section below, and I'll be happy to answer your queries. Thank you once again, and have a nice day.